Good morning to everyone. Dear student, welcome to class 8th. Today we are going to have online classes of class 8th mathematics chapter number 1 rational number. Okay. So, in the Google Meet I had already given you some introduction of the rational number. So, here in this chapter we are going to see the definition and the properties of a rational numbers. Okay, and in the 7th class what you people had already studied? In the 7th class you people had already studied about natural number, whole number, integers and fraction. Along with the fraction, decimal also you people had studied in class 7. So today we are going to have the rational numbers. Okay, so before starting the definition of a rational number, I am going to just give you a verbal definition of natural number, whole number, integers and fraction. Clear? So, what do you mean by our natural numbers? So, what is our natural numbers? All the counting numbers are said to be as a natural numbers. What is a counting number? Counting number. So, all the natural number are said to be a all the counting numbers are said to be a natural numbers, where the counting numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the counting numbers which is said to be as a natural number. Clear? Next we are having whole number. Suppose I am having a bag. Okay, this one is a bag and this bag is filled with the counting numbers. Clear? This one is a bag and this bag is filled with the counting numbers. A zero comes from outside and it get inside to this bag. Then this bag carries counting numbers as well as the zero. So hold together all the counting numbers along with the zero is said to be as a whole number. Clear everyone? If we are going to remove this zero from the bag, suppose this one is a bag we are having. Okay, this bag is carrying all the counting numbers 6, 7, 8, 9. So these are the counting numbers. If a zero does not enter in it, if a zero is present in its place, it does not enter in this bag, then it is said to be as a natural number. But when zero enters inside the bag, it will become a whole number. So dear students, a minor difference between is there between natural number and a whole number. What is that? Is zero. With zero, if our natural number if we are going to add zero in the counting number, it will become a whole number. If we are going to remove zero from the counting number, it will become a natural number. Only it is about a zero. Okay, if zero is present, then it will be a whole number. If zero is not present in the counting number, then it will be a natural number. A simple difference between a natural and a whole number. Clear everyone? Next is a integer. Integer also you people had already studied in last year. What is integer? Suppose I am having a bag over this. Okay, and this bag is filled with all the positive numbers and all the negative numbers. Dash dash dash, that means infinity. Okay, this is a bag and this bag is filled with all the positive and negative numbers along with zero. Zero is compulsory to be present. Okay, as we know that zero is a neutral number which does not have any sign, neither it is a positive sign, neither it is having a negative sign. Okay, so hold together the positive numbers and the negative numbers along with zero is said to be as integers. The group of positive numbers or negative numbers along with zero is said to be as an integer, or in other word also we can say that a combination of positive numbers, negative numbers along with zero is said to be as a integers. Clear? We had already seen the integers definitions and properties last year, isn't it? So what are the properties of integers we are having? Same properties is going to be followed for the natural number, whole number and also for the rational number. Remember, okay, same property will be there. Only the difference is the presentation of the numbers in that. If suppose we are talking about a decimal, then decimal number will come, but the property name will remain same. Okay, if we are talking about a rational number, then the rational number, that means it will become in the form of a fraction. Only that much difference. Rest other, the name of the property, the operations will remain same. Even the solutions part of those property will be same in this whole. Okay, so about the integers we are going to save the properties. Since integers is definition is over, example also you had studied, the type of integer will be positive, negative and neutral. These are the three types of integers which you people have already studied, isn't it, in the last year. So what is the property of integers are? Properties of integers are, first property is addition property. Second one will be subtraction property, isn't it? Third one is a multiplication. And fourth one is a division. So these are the four properties of integers. And the same four properties we are going to see for the rational number also. Inside the addition property, again 4 to 5 properties comes, like for example closure property, associative property, then commutative property, additive property, isn't it? Then identity. Like this 5 properties comes under addition. In the subtractions, all the properties comes but does not exist. That means LHS, when we are going to solve those properties from LHS and RHS, it will not be equal. The answer will not be equals on both the side. That's why subtraction properties of closure only exist. Rest other like associative, commutative, all this does not exist. Okay. Then multiplication, again the same property exists. Okay, that like closure property exists, additive exists, then not additive, that is multiplicative identity. Then inverse of 0, commutative. Okay, like this the property exists in the multiplication of division. Next is division property. In this division property of integers, again the first property, that is closure property, exists, rest other property does not exist. Clear up to here? Now what we are going to see, student, the main topic here we are going to start is a rational number. So in the Google Meet I had already given some introductions of this chapter, isn't it? That is a rational number. So the number of the form a by b, where a and b are integers and b is not equals to 0, are called a rational number. Dear student, a rational number can be a by b, that means where a by b, where a is numerator and b is the denominator. Okay, in place of a by b we can put p upon q also, c by d also, then x by y also. It is not compulsory to put only a by b or p by q or c by d. You can use any alphabet. Okay, the thing is that it is in the form of a fraction. Clear? So the number of the form a by b, or you can say p by q, c by d, x by y, any alphabet you can place in the numerator and denominator. So in order to be a rational number, it follows two conditions. First condition is that numerator, a is numerator, b is denominator, isn't it? So both numerator and denominator should be integers. Integers, that means positive, negative and neutral numbers are said to be integers, isn't it? So it should be, the value of a by b should be, first condition is that it should be integers, and second condition is that its denominator never be equals to 0. Denominator जो होगा वो कभी 0 नहीं होगा. For example, a by b we are having, isn't it? That we can, 1 by 2 is an example. Okay, then 4 upon minus 16 is an example. Also minus 3 upon 8 is an example. Clear? 0 upon 2 is an example. So these are the examples of a rational number. Clear everyone? Now can you tell me whether 2 upon 0 is an example of a rational number or not? This one is not an example of a rational number. Why? Because its denominator, that is the value of b, never be equals to 0. Clear everyone? So here the definition is over. Tomorrow we are going to see about the properties of it. Clear? So for today, thank you everyone, and can ask the doubt directly through my WhatsApp number. So for today, thank you.